students, I'm Dr. Anita Sharma. Welcome in my chemistry class. In this lecture, I'm going to explain phase diagram of two-component system and I'll take the example of silver lead system. So without further ado, let's begin. Physical Chemistry, paper 202. In this lecture, I'm going to explain two-component system and will take the example of silver lead system as per the syllabus of Gujarat University. So before starting silver lead system, we should be familiar with some terms like simple eutectic system. So what is the meaning of eutectic system? So eutectic word comes from Greek word eutectos, and here the meaning of eutectos, eu means good and tectos means melting. So eutectos means easily melting. If two substances are completely miscible in liquid state but immiscible in solid state, it forms a simple eutectic system. Since we are taking the example of silver lead system, silver and lead in their melt forms a homogeneous mixture, means they are completely miscible in their melt state or melting form, but they are not miscible in their solid form. So they form eutectic mixture. That is why this system, silver lead system, is also known as eutectic system. The mixture that has the lowest melting point is called eutectic mixture, and the temperature at which it crystallizes is as a whole is called eutectic temperature. So eutectic temperature, eutectic mixture, we are now familiar with the term eutectic mixture, homogeneous mixture of two substances which are completely miscible in its liquid state. Eutectic temperature is the temperature where this composition start crystallizing, and minimum freezing point of eutectic mixture is known as eutectic point. Now we have to start two component system since we have taken silver lead system. So first we will discuss how many phases are there, why it is called two component system. So minimum number of components required to express all phases of system is, in this system it is 2, because in silver lead system all the phases, for the presentation of all the phases, minimum two components are required, that is silver and lead. So it is possible to express the composition of all the phases in terms of two substances. That is why it is called two component system. That we have seen in water system also. Water system is called one component system because for the presentation or representation of all the phases of water system, only one component is required, that is H2O. Here for the presentation or representation of all the phases of this system, minimum two components, that is silver and lead, are required. That is why it is called two component system. Now we will see the phase rule for two component system. In phase rule, this F is equal to C minus P plus 2. So basically if we apply this F is equal to C minus P plus 2 phase rule for two component system, what could be the degree of freedom? Because minimum possible phase could be one. Minimum possible phase, like in areas normally only one phase exists. So if we are considering one phase, minimum possible phase is 1, and we are applying this rule, then we will get 3, degree of freedom 3. And if degree of freedom 3, it means minimum 3 independent variables are required at a time to present a system, which is not possible in phase diagram, because in phase diagram on x-axis and y-axis we can take only 2 independent variables. And since we are talking about metals, so in case of melting point, pressure can be taken as constant, that is 1 atmosphere. So in two component system, what we can do, we can take pressure as constant, that is 1 atmosphere. And this kind of system where pressure is constant, we consider pressure is constant, that system is called condensed system, which are studied at 1 atmosphere. So for condensed system, this phase rule changes, and the phase rule will be F is equal to C minus P plus 1, because we are not taking here 3 variables, only 2 variables we are taking at a time. So So, when two metals are completely miscible with each other in liquid state and do not form any chemical compound, then that kind of mixture is called eutectic mixture. And in this phase diagram that we have seen, no effect of pressure on equilibrium. The temperature and composition are considered to construct a phase diagram at constant atmospheric pressure. The vapor phase is not considered and condensed phase rule is applied, because vapor phase we cannot consider here because melting point of lead and melting point of silver is very high. So first they will melt, then boil, and then vaporize. The possibility of this kind of phase is very much negligible. So now we will see how many possible phases can exist in silver lead system. So basically in silver lead system, three possible phases are solid silver, solid lead, and solution of silver and lead. Solution of silver and lead means the melt of silver and lead which is forming a homogeneous mixture. The possibility of this vapor phase is very much less. Now we see the phase diagram. This is a simple phase diagram of silver lead system. In this phase diagram, here this point is showing 100% lead and this point is showing 100% silver. On this point, since 100% lead is present, this is the melting point of lead, 327 degrees Celsius. And here, since 100% silver is present, this is the melting point of silver, that is 961 degrees Celsius. These two curves we have to see, we have to study in this silver lead system, A, O curve and B, O curve. This O is called eutectic point and this temperature, 303 temperature, is called eutectic temperature. So, how many phases will be in equilibrium at particular curve, that AO? How many phases will exist on curve BO, and what is the condition, what will be the degree of freedom here on eutectic point, what is the degree of freedom on the curves, that we have to see, and what could be the composition at eutectic temperature, that we have to understand in the phase diagram of silver lead system. So one more figure I will show you, but before starting that figure, first you have to see here, since this is the melting point of lead, so above this temperature lead will be present in its melted form, and this is the melting point of silver. So above this temperature, so in this area only liquid melt will be present, liquid melt of silver and lead will be present. And on this curve, so what is happening on these curves? On this curve, one thing is happening by the addition of silver in lead, because this is 100% lead, and as silver start mixing, so by the addition of silver in lead, melting point of lead is decreasing, and on this curve by the addition of lead in silver, melting point of silver decreasing. That I will see in another diagram. So this is phase diagram of silver lead system. So in this phase diagram here I have written also 100% lead is present, here 100% lead, and here 100% silver is present. This is a melting point of silver and this is melting point of lead. And here one thing you can see, by the addition of lead in silver, the melting point of silver is decreasing, here you can see. And here on this curve, this BO curve, by the addition of silver in lead, melting point of lead is decreasing. So earlier the melting point of, here you can see, of lead is 327, melting point of silver 961, and a homogeneous mixture we are getting by the mixing of lead and silver, which is showing the melting point 303. So this homogeneous mixture is called eutectic mixture because it is completely miscible. In melt form of silver and lead they are completely miscible, but they do not react chemically. So temperature of eutectic mixture, or the melting point of eutectic mixture is 303. Below this temperature, this mixture starts solidifying. So now how many phases can exist on these curves? So on this curve, first phase, that is homogeneous mixture of silver and lead exist plus solid silver. So two phases can exist on this curve, and on this BO curve, homogeneous mixture of silver and lead plus solid lead, means two phases can exist here also. And at eutectic point, how many phases can exist at eutectic point? So at eutectic point, solid silver, solid lead and homogeneous mixture of silver lead can exist. So what we can do, we first have to see the degree of freedom. So when we calculate degree of freedom here by applying condensed phase rule, that is F is equal to C minus P plus 1, degree of freedom at eutectic point will be 0. And on curve, degree of freedom will be 1, because two phases we are taking here also. But remember, we have to apply condensed phase rule here because we are considering pressure as constant. And above these two temperatures, silver and lead exist as liquid, so only liquid phase will be present here. And below this temperature, in two compartments you can see. So in this compartment, lead compartment, eutectic liquid plus solid lead will be present, and here eutectic liquid mixture plus solid silver is present. And at eutectic point, the composition of mixture is 2.6% silver and 97.4% lead. This is the composition of eutectic mixture. Here you can see here 100% silver was present. So as we go far from this point, the percentage of silver decreases. So here the percentage of silver will be 2.6%, and this is very close to the point where lead was 100%. So here 97.4. So this is eutectic composition. Now I have explained these curves one more time here, curve AO and curve BO. So curve AO is also known as freezing point curve of silver, and the melting point of silver is 961. So as we go down, silver is freezing because this is the topmost peak of silver. Here BO is called freezing point curve of lead. AO curve shows decrease in freezing point, melting point of silver due to the addition of silver to lead, and BO curve is showing decrease in melting point of lead due to the addition of silver to lead. On AO curve, solid Ag is equilibrium with solution of silver in lead, and BO curve, solid lead is in equilibrium with solution of silver in lead. So when we apply condensed phase rule here, I have applied here C minus P plus 1. So if components are 2, phases are 2 plus 1, so degree of freedom will be 1 at curves. And here system will be univariant. And point O, 3 degree temperature, eutectic mixture, melting point, and the composition is this that we have discussed many times. So basically what could be the degree of freedom at eutectic point, that also we have to understand, because this I have already explained in curve. What is the temperature, what is happening on the curve, that I have explained in that phase diagram. So point O is called eutectic point, where 3 phases, solid lead, solid silver and their liquid solution coexist. And it is an invariant point. The temperature of eutectic point is 303 and the composition 2.6 and 94.7. So here degree of freedom will be 0. So why? F is equal to C minus P plus 1, components 2, phases 3. So degree of freedom will be 0. And system is invariant, and this is the composition. One more time you can see. And it is called eutectic point. So this is all about silver lead system, which is also known as eutectic system. These are the references. Thank you.